Hey, and welcome to day 11, people. It's not long now until the exam, and hopefully you're feeling a bit more confident than you were when we first started the program. So this is the one, actually part 2 of question 7 is the one that you guys voted pretty high. I can see why it looks kind of crazy, but we'll do part 1 first, because often how these things work is that the stuff from part 1 that you learn that you then apply in part 2, and because I haven't done this one yet, I've got to find out what that is. So for part 1, we've got a trig equation here, 2 cosine squared theta equals 3 sine theta. I check my domain over here, so I know that my answer is in degrees, and it's between 0 and 360 degrees. And the other thing that I know is that at this stage, it's got 2 different trig functions in it. So I need to, first of all, put it into one. And hopefully we're good at this now that we're like, well, what do I know? If I tried to replace a sine theta with anything, it would be cosine theta times tan theta, which won't help me, right? But on this side, if I replace that cosine squared theta by doing a sneaky rearrangement of this little baby, so we know that sine squared theta plus cos squared theta equals 1. That means cos squared theta equals 1 minus sine squared theta, right? So I could just replace cosine squared theta with 1 minus sine squared theta. And that works better as a substitution because now everything is in terms of sine. So if I expand that out, I get 2 minus 2 sine squared theta equals 3 sine theta. And if I rearrange this all to the right-hand side, I get 2 sine squared theta plus 3 sine theta minus 2 equals 0. So what I've got is a quadratic in terms of sine. So I can still factorise it like I would normally with a quadratic. What you can imagine is that that's like a big x squared and that's like a big x. Okay, so you still factorise it how you normally would. So you find your 2 brackets, like so. One of them's going to be 2 sine theta. The other one's going to be sine theta. And the other one has to be either -2 or 1 or -1 and 2. But we know we need to get 3 as a result, so it's going to be this combination here. Because here, 2 sine theta times 2 will give me 4 sine theta, and then I'll take away 1 sine theta to get 3 sine theta, and then I'll get -2 by multiplying -1 and 2. So then all that's left is for me to solve 2 equations. I do them on 2 sides. I've got 2 sine theta minus 1 equals 0 as one of my equations, and sine theta plus 2 equals 0 as the other one of my equations. Now, normally how this works is to make it nice for you. What you'll find is one of these ones won't work, so that they don't make you do too much work for this. So if I do a slight, let's start with this one here, sine theta equals -2. This one here I can't solve, because if you remember the sine function, like so, it's going up to 1 and down to -1. So sine theta equaling -2 all the way down here is not going to work. So that's not going to be a possible one for us to explore. If we go back over here, we're going to get 2 sine theta equals 1. So then sine theta equals 1/2. And so then our first theta value, so make sure your calculator is in degrees, which mine is. I was just checking really quickly then. And let's do the inverse sine of 0.5. Oh, get 30 degrees. I should know that one. It's a special triangle one. Anyway, 30 degrees. And that means that my other solution, so think about it. We've got our sine curve there. We've got half across like that. So that's our first solution at 30. So our other solution is going to be at 180 degrees minus 30. So it's going to be 150 degrees is our other solution. Okay, so that's part 1. And on to part 2. So what does it say here? The smallest possible positive solution of this equation, where n is a positive integer, is 10 degrees. So let's just write this out. So, a pen, sorry, 2 cosine squared and some factor of theta equals 3 sine, again some factor of theta, where n is positive. So n is going to be above 0. and it's an integer. Okay, so basically we're looking at values like 1, 2, 3, 4, 5, 6, 7, 8, 9, so forth. So first of all, just let's remind ourselves what it means to have an n in front of theta. In fact, actually, let's go further. We've already taken part 1 and turned that into a better looking equation to help us solve it by putting in our trig identity kind of stuff. So let's do that now again as well. So we're looking at this from a better perspective. So if you remember what we got to last time is we got to 2 brackets factorised, and we got to 2 sine theta there, and we got to sine theta there, and we got to plus 2 there, and we got to minus 1 there. Okay, and what we know about sine functions is we're still looking at a domain of 0 and 360 degrees. And what we know is that if n is 1, it's going to be, we're going to get one period being 360 degrees, right? When n is 2, we're going to get, sorry, that should go down lower, we're going to get our period being 180 degrees, which means it looks like we've got 2 sine curves in the space of 360 degrees. And if we go further and we go to n is 3, so it's like sine 3 theta, the period would now be 120 degrees. So we would fit in 3 in the space of there. So something like that. It didn't work out very well. Of course, all of these curves, I haven't drawn them very well because all of these should have an amplitude of 2, so up by 1 and down by -1. Maybe that's an amplitude of 1, I don't know. Anyway, right, so all that's changing is the period of each of those curves. Okay, so if I go back here, what they're saying is we're going to have our n value there, so n theta minus 1, and our n value there, plus 2 equals 0. So if we had different n values, we'd still factorise, we'd still be looking at these solutions. And we already know from last time that this one here is not going to work. It doesn't even matter what the n value is. As soon as you take that and make it equal to 0, you're going to make it equal to -2, and -2 is all the way down there. Okay, so it's not going to work for our scenario. So we're back looking at this one here. Okay, and that's our n value there that we don't know what it is just yet. Okay, I'm just going to put brackets around like they've got just to make it a little bit clearer. Okay, so what we found before was that when we solved 2 sine theta minus 1 equals 0 and we rearranged it, our smallest solution between there was 30 degrees, right? And what they're saying here now is that the smallest solution is 10 degrees. Okay, so if you think about it, this is all about some sort of scale factor. So that is, if you divide that by 3, you get 10 degrees. Okay, so that tells us that we're going to be, what's the word for it, compressing the sine curve so that we are making 3 of them in that period of 360 degrees. So that means that n is 3. Okay, cool. So now we know that n is 3. Let me just move this stuff up. There we go. We know that n is 3, so let's go back here. So we're solving the equation 2 sine 3 theta minus 1 equals 0. Don't know why I'm writing it all out again. Right, so we've got to that point there. Equals a half. Okay. And then when we do the inverse sine of that, you get 3 theta equals 30 degrees, so theta equals 10 degrees, which is what we knew before anyway. But what they're asking us in this question is what's the largest possible value of theta? Okay, so we know that the period of our sine cycle, is that the right word, is now 120 degrees. Okay, so we can fit, I'm going to draw that again actually because that's a really bad drawing. Let's go back here. So we know here that between 0 and 360 degrees, the period of each sine cycle now is 120 degrees. So there's our markers there, 120 and 240. So it's going to go up and down, up and down like that. And our smallest solution here is 10 degrees from 0 that way, okay? Our largest possible answer is going to be this one over here, okay? This last one here, which is going to be 10 degrees back from whatever is halfway between 240 and 360. Okay, so halfway between 240 and 360 is 300 there. So if we take 10 degrees off that, back that way, we're going to get the largest solution is that theta equals, what did I just say? 290 degrees.